actually in this talk. You know, okay.
Yeah, it's
Now,
coming.
you know, just like just some people gather in a particular region and form a country, just like say Japan, say Bangladesh, say India, and so on. So in this way, the stars in the sky just gather in a particular region, and we call that particular region of stars as galaxy. And you know, the number of galaxy in our universe is 10 to the power 11 galaxy. And you know, each galaxy contains nearly 10 to the power 11 stars. So you can imagine uh, how big our universe. And you know, as sun is a member, one of the stars, so sun lies in our galaxy. You can see this is our galaxy. Okay, so this is our galaxy, and it is known as Milky Way, or better, it is known as Akash Ganga also.
Yes.
See that if you start from this left region and start his journey for a light, and this light just takes 10 to the power 5 years to reach the other end.
Correct.
So you can see how large our galaxy, that is Milky Way. So this type of galaxy, there are 10 to the 11 galaxy in our universe.
Yeah.
And this our galaxy has a thickness, you can see that 500 light years, the thickness of this our galaxy.
Yes.
And actually, the stars, how can we identify stars? Actually, to see some characteristics, one can identify stars. So usually in the ancient time, Greek particularly, the identify stars by seeing its brightness as well as color. So just identify a star by its color and brightness. They are grouped in 6 groups, and that each group is known as magnitude. So the brightest star is the first magnitude, and the faintest is the sixth magnitude. But nowadays, more bright and more faint stars are found. You can see that different colors and different types of stars. So the seeing these stars, we can identify which study it is. And before actually 1840, just people used naked eye to identify a star. But after that, the advancement of science, now people use the photoelectric method. So you can see that a light comes from stars, and this is a cathode of a photocell, and resulting current is amplified, and one can record it a pin record, and that the deflection is directly proportional to the intensity of the light. So in this way, we can just find a stars with different characteristics. Now, interesting result has been found by 2 scientists. One in 1911, name is Hertzsprung, and 1913, Russell. Independently observe the stars, just observe 2 characteristics. One is luminosity and its surface temperatures. You can see that just identify stars by its luminosity and surface temperatures, just like our 2-dimensional geometry. That is, say, Cartesian coordinate. Every point can be represented as 2 coordinates, that is x and y coordinate. So in this way, luminosity and surface temperature has 2 coordinates, that is, say, surface temperature as the x coordinate and luminosity is the y coordinate. Then every point can be represented as a star in 2-dimensional geometry, that is Cartesian coordinate system. You can see that this is the position of the stars, and they have found a peculiar result. What the result? Most of the stars lying, you can see that left corner, top left, top corner, left top to right bottom. So in this region, most of the stars lies if we use these 2 characteristics of a star. And more than 70% stars lying in this particular region. This is known as main sequence star. And you can see that this is the position of our sun. And some stars lies in the lower bottom, left lower bottom. This is known as white dwarf. And some stars lies in this right upper right corner. This is known as giant or supergiant stars. And you can identify stars or measure stars, arbitrary stars, in terms of a standard source of light. So sun is the most standard source of light. That's why we need to know some characteristics of the sun. What is the characteristics are? That is mass of the sun, say 1.98 into 10 to the 30 kilogram is diameter. 13900 kilometers and so on. So if you know these characteristics of the sun, so one can measure the stars in terms of sun's characteristics. Also, you can see that the sun contains nearly 70% hydrogen, 28% helium, and other elements, oxygen, carbon, neon, iron, etc. Only the remaining portion. And they have the Russell, Hertzsprung and Russell on a peculiar result. What's the result? This is a purely an observation result. We can see that if we choose an arbitrary star with luminosity and the mass of this arbitrary star same, then this arbitrary, the luminosity and mass of the arbitrary stars is related with that quantity, with those quantities of sun. That is L. This you can see that just dot circle. That means the luminosity of the sun. Again, you can see that mass, that is M dot circle, that is the mass of the sun. So if you can choose the arbitrary star, then you can see that all the arbitrary stars is related with the sun's characteristics. That is sun's luminosity, sun's mass, sun's radius, sun's mass, etc. and so on. This is purely an observational result, no experimental result, no theoretical results. So if you just able to find the luminosity of a star, then using this relationship, we can easily find its mass. So this is a very important result for astrophysics. This is an you can see the picture of Betelgeuse, the giant star. You can see that its mass is 20 solar mass. This is actually the artistic picture, not exact picture. This artistic picture of a giant star. This is Betelgeuse, and its mass is say 20 solar mass. You can see that with a measure the sun, measure the mass in terms of solar mass. Also, its radius 1,200 times of radius of the sun. This is another star which is known as a very well-known star. We can see the naked eye. This is Sirius B. This is a white dwarf star, and we can see that its mass is nearly 1 solar mass, but its radius is 0.008 times of solar radius. Now, another next important question: how a star is born? You can see that in the universe there are so many dust and gas, and gravity draws all these clouds together. Because gravity has the attractive nature, and we can see that all the dust and clouds just comes together and form a new body. That body is known as protostar. Okay, but if the just collapsing materials that form the body, the mass of the body is less than 0.08 times of solar mass, then that is a star, but that is a never twinkle. That is known as brown star. That's a never twinkle. But if its mass, the collapsing material, mass of the collapsing material is more than 0.08 solar mass, then we find a stable star. Now the question is how a star is stable, because due to gravitational attraction, all the matter is starting collapsing. So how we can get a stable star? You can see that there is a interesting explanation for this stable star. How? Now, in the core of the body, that is collapsing body, that is hydrogen, and due to collapsing materials, the core of this body, the temperature of this core of the body will get high, and then a new reaction is started. What the reaction? That reaction is known as fusion method. Fusion reaction. What is the fusion reaction? Then hydrogen convert into helium. So in this method, there is enormous pressure, outward pressure produced. Then the star is stable. Gravity inward pull in, exert inward pressure, and the fusion method produce outward pressure. Then we can find a stable star. So this is one of the interesting explanation to get the stable star. Now another question is how much its star is stable, or the lifetime of a star. Now you can see that if the initial mass of the star is 10 solar mass, then its lifetime is 20 billion years. But if a star of mass, say 0.5 solar mass, then its lifetime is 80 to 100 billion years. So that means heavy mass has low lifetime, but low mass has high lifetime. Now, another interesting question is, now you know, say you all know the Ambani, Bill Gates. Definitely, you have heard the term this about this big businessman. Now, what will happen if Ambani or Bill Gates stop their business? What will happen? Then all the money will be exhausted very quickly, and they become poor. So in this way, if all the hydrogen in the stars has been exhausted, because there is no produce of hydrogen, so one day all the hydrogen will be exhausted. So there is no fusion method. So there is no outward pressure. Then the stars again started collapsing. And the big name Subramanian Chandrasekhar from our Indian scientist who got Nobel Prize. He did a calculation when he was in master's students. He shows that if the initial mass of the star is 1.44 solar mass, less than 1.44 solar mass, then after exhausting all the hydrogen, this star becomes a white dwarf. Now, again, question: what will happen if the initial mass of the star is more than 1.44 solar mass? I mean, say 2 or 3 solar mass. What will happen? Then, after exhausting all the hydrogen, the star becomes neutron star. Now, again, question: if the initial mass of this is more than say 9 or 10 times solar mass, what will happen if all the hydrogen will be exhausted? Then, after exhausting all the hydrogen, the collapsing material form a new type of object. That object is known as black hole. You can see that this is a pictorial. You can see that in the star, that in the fusion method produce energy, that outward pressure. And if all the hydrogen has been exhausted, then there is no fusion method. Then due to gravitational field, the star becomes collapsing because there is no outward pressure to balance it. So one day, this star has found out that it is known as supernova. So in this way, one can find a new object if the initial mass of the body is high mass, that is 9 or 10 solar mass. We have a new object that is known as black hole. So what is the black hole? Actually, black hole is a very powerful gravity that can grab the smallest or largest things. Or more popularly known as black hole has so strong gravitational field, light can escape from this region. So this is the most popular assumption about the black hole. The light cannot escape from this region of the black hole. Now, Einstein proposed a theory which is known as relativity of relativity in 1915. In that year, one of the solutions found by Schwarzschild, the solution predict a new solution that is known as black hole. But at that time, this is purely a theoretical concept, no observational evidence at that time. But Einstein theory predict the new type of objects can be found in our universe. Now, in the Einstein theory, one interesting feature is that if there is a mass, then mass distorts its nearby space-time. And if a particle or mass or massless particle, that is light, pass nearby this heavy body, then that light or particle has to follow this curved path. That is the bent path. And the proof of this proposed theory, that is Einstein's relativity, is in 1920 by Eddington. You can see this is a video. You can see that suppose this is star just behind the sun. Okay. Now the light comes and passes nearby sun, and you can see that the light comes when it comes from the nearby. This is the seas of sun. Due to presence of sun, the nearby space-time will be bent. Then light just follow this bent path and say this is our Earth. This is the position of our Earth. So we can observe. You can't see the curved path. Rather, we see the straight line. You can see again. See that. We can see that I'll just repeat once again. This is the actual position, but we observe the star in a straight line. That is when we stop the actually this is has been proved when a solar eclipse was in 1920. So after solar eclipse, we can see the star, and this is one of the fundamental proof of Einstein's theory of relativity. Now again, I have told that if there is no light comes from the black hole, so how can we identify a black hole? Actually, there is up to 2019 there is no direct proof. Just but apparent proof has been found. How the apparent proof? Now the one of the proof is known as accretion disk. You can see that to see the accretion disk phenomena, one can realize that in that region there is a black hole. You can see this. Look at pictures. Suppose black hole has heavy high gravitational field, so it attracts the nearby stars and suck the matter, and that matter comes from the nearby stars. This is sucked. That you can say this is the nearby star, and it has the position of this black hole. Due to a strong gravitational field, it sucks the matters, and that matter is starting rotating around this particular region. You can see that this is region. Actually, this region, people predict that this in this position there should exist a black hole. So in this way, we can find the indirect evidence of black hole. Now, actually, black hole grabs the nearby stars only, nearby stars, and there are millions black holes are found in the galaxies, and you can see another interesting pictures. Actually, this is the artistic picture, not exact picture. You can see that after just grab the stars, just like the black hole just take its lunch, and after the lunch, there is so matters are coming out from this black hole. So just like it is vomiting just. So after taking the lunch from by the stars, this black hole take the lunch from the stars, and after the lunch is vomiting. This phenomena has been found through advanced telescope. But the first black hole has been captured in 2019. This is captured by the telescope which is known as Event Horizon Telescope. Okay, this is first black hole has been found in galaxy M87 galaxy. Okay, this is actually far away from our Earth, nearly 50 million light years away from us, and its mass is 4 million times of solar mass, And in Event Horizon Telescope, nearly 200 scientists are working. They are coming from mathematics background. They are coming from physics background. They are coming from statistics background. They are coming from engineering background also. So there are 200 scientists are working in this project. This is the picture captured by Event Horizon Telescope. And what is Event? I just say 1 or 2 minutes about Event Horizon Telescope. Actually, Event Horizon Telescope is not a one telescope. This is actually a system of telescope put in different parts of our universe, in our inner world. Say Mexico, United States, Chile, South Pole. So all the telescopes actually work together. Okay, and finally they collecting all the data, then ultimately produce the capture that will produce this black hole. And you can see that how powerful this Event Horizon Telescope, just be simple, just a how powerful this Event Horizon Telescope is. I just see this telescope. Suppose a man, you can see that a man is standing nearly 25 miles away. Okay, standing 25 miles away, and if you zoom the telescope, what will happen? You can see the man who is far from the telescope. There is 25 miles away. If you zoom, further zoom, okay, further zoom, you can identify the man standing man is standing up. Okay, so if you again zoom further, then you can see the face of the man. Zoom further, you can see that the hair of the eyebrow. Again, you zoom further, you can find one of the hair in the eyebrow. Again, you zoom further. Again, zoom. Again, zoom. What you see that this is a microscopic structure of a hair. So you can see how powerful this telescope. So this telescope first captured the black hole, that is Even Horizon telescope. Okay. Now the features of black hole. The black hole has some particular features or some characteristics. What are the characteristics? Black hole has a singularity. Actually, singularity is a point where all the physics law, all the physics, there no physics law is working. So you can see, or you can remember, this is a point-like position, but its density is infinite density. So in this way, we can identify a singularity. This point-like position is point-like, but its density is infinite density. And also you can see that this singularity is bounded by a region which is known as event horizon. I can give an example. Suppose you have a garden and a well in the middle of the garden, and the garden is bounded by a boundary. Okay, so you just think outside the boundary, you can't see the well. In this way, you just light the outside of event horizon, then you can't see the singularity. Now, again, question: what will happen if we just outside the singularity, the position outside singularity, you can come out, or the position of the light comes out. If the position of the light just outside the event horizon, but if it's on the light on the horizon, then light will be stationary. So light stop there. So on the horizon, light stop their journey. So light just stop its journey. But if it is within the light cone, then it goes inside. Now I give a classical argument about the black holes, very lucid sense. Suppose a heavy mass, capital mass, body with capital mass and a radius, say capital R. Okay, and a particle with small mass and velocity is v is moving in this territory of this heavy mass area or heavy body region, that is with mass is m and radius capital R. Then we can find this kinetic energy and potential energy. So we can get the total energy. What is the total energy? Is the kinetic energy plus minus dm by r. This is the potential energy. So now just throw a particle just which goes to infinity. So if somehow if we are able to throw a particle where it goes to infinity, then it's at infinity is velocity 0, and the distance is the arc tends to infinity, that is at the infinite distance. What will happen? From the previous equation, that is this equation, you can see that E equal to 0. So in this way, we can get the concept of escape velocity. So if you write the escape velocity, the formulation is v square equal to 2 gm by r. G is the Einstein Newton gravitational constant, and capital M the mass of the gravitating body and its radius. Okay, so you know the escape velocity of the Earth, that we know 11.2 kilometer. So if a particle throw with 11.2 kilometers, then the particle can never come back, because this is known as escape velocity. So if we standing in the moon, then you throw a particle. Anyone know what is the escape velocity of moon? Anyone? Anyone? The participant, anyone who can tell what is the escape velocity of moon? Okay, no problem. Actually, it is 2.4 kilometer. Now again, what is the escape velocity of sun? Anyone? Okay, no problem.
Obviously,
actually 615 kilometer per second. So if we throw a particle standing in the sun with velocity 615 kilometers, then it goes to infinite. That is the escape velocity of the sun. So in this way, if we need the escape velocity c, then using this relation, one can see that if a mass of the body is capital radius capital R, then according to previous formula, the velocity is capital C. So to get the escape velocity in this region, you need to follow this relationship. So from this mathematics, we can use the we can find the radius of the gravitating body, that is M, whose mass is capital M and radius is capital R. With this relationship, that is this formula, then one needs to use the velocity more than velocity of light. That is more than velocity of c. C means the velocity of light. So that is 3 lakhs kilometer per second. So in this way, if a body has the radius capital R with this particular formula, then one needs the escape velocity to get the escape velocity more than velocity of c. So this formula is known as, or this radius is known as Schwarzschild radius. So if anybody, if we just squeeze into this radius, you can see that this radius, I just circulated this radius, then one needs to get the velocity, to get the escape velocity more than velocity of c. So this body now becomes a black hole because it needs to escape light with more than velocity of c. So in this way, one can easily develop a black hole manually. Actually, the theoretically. Now, for the case of Earth, now if we squeeze the Earth with the radius 0.9 centimeter, then Earth become a black hole. You can see that for the Sun, if we squeeze the Sun with 300 kilometer, then Sun becomes a black hole. Now, this is an interesting example. Now we can develop, or we can construct a human black hole. How? Suppose the Aziz is here, present here. So Aziz has weight, say 60 kilometer. So if we just squeeze the Aziz in the radius, Schwarzschild radius, say 10 to the power minus 33 meters, then light needs to escape from this Aziz body more than velocity of c. Now Aziz become a black hole. So in this way, we can develop or construct a living black hole. Definitely, this is theoretically. Now, Aziz density is 10 to the power 94 kilogram, according to this formula. Now, another interesting historical concept is known as black hole of Kolkata. Now, we know Siraj-Daula, the last Nawab in our country. So in 1756, actually English man demands that Siraj-Daula put thousands of people in a 10 by 10 foot room. All the soldiers, English soldiers put 10 by 10 foot room. So if small region, so many soldiers put in this small region, so people just term this event as black hole of Kolkata. This is a purely historical concept or region. Now, another interesting event is what will happen if Sun become a black hole. What will happen? Actually, nothing will be worried, except we are with the planets moving around the Sun, no problem, because mass is fixed. So Sun becomes a black hole, doesn't matter to us. But one problem, light cannot come out from the Sun. And if there is no light, there is no plants in our world. So there is no oxygen, so we will be die. So except our Earth and Mercury and also other planets, just moving is as usual. But there is no living body present in the Earth. Now, this is another just for the students' interest. If we just measure the weight of a man in our Earth, say 150 pounds, and if they measure that people or that man in the moon, his weight will be only 25 pounds. In Jupiter, his weight will be 350 pounds. His weight in the Sun will be 4,000 pounds. But his weight near the black hole, 20 trillion pounds. Just imagine it. And this is an schematic. This picture, I have mentioned that light will be bent when it passes through a very heavy object. So this is sun is a very high masses object. So if light passes near the sun, then this light will be deflected is 1.75 second. This theoretical prediction has been proved by using Einstein general theory of relativity. So that's why Einstein general theory of relativity is the most beautiful theory in 20th century. People call it. Now, again a schematic picture. Now, if this is a say star and if we draw a light, then the path of the light like this straight line, there's no problem. It is a white drop is just in the present, it just lie in the white drop and just draw a light. The path of the light is slightly bent. And if we just standing in the neutron star and just draw a light, the path of the light will be bent, more bent like this. Now, if you lie in the star, it's a black hole, and draw a light, that light comes back to. So there is no light comes out from the black hole. This is purely a schematic picture. Now, another interesting issue is what will happen if one will fall in the black hole. What will happen? Now, black hole has enormous gravitational field. So that's why if you just fall in the black hole, then the distance from the black hole of your foot and your head will be different, slightly different, but due to heavy gravitational field, so your foot is attracted more. Then actually you become a Chowmin like this. Just like this, just you become a just in this particular figure you have you just looking in the skin. Now, it is not possible to observe a black hole directly unless one has a great fortune to see a star disappear. So I have to stop my
black hole yes meeting
just a minute. Just a minute. I have to stop my talk here. Just saying a story. Once a woodcutter, woodcutter, just enter in the forest to cut some trees. So after sometimes he becomes hungry, so start cooking. So he draw a light to start cook, and under a tree. And in that tree there is a nest of bees. Bees. So when they set fire, then there is smoke comes out. So bees, the nest of the bees in the queen and other bees are become very disturbing. And then queen and just call a urgent conference. So what is this in the ground? Then every bee is just sitting around the queen. Then one bee stand up and told that, okay, I will see what the things in the ground. So he comes around the fire and came back. This is very warm. This is a warm thing. Hello, everything, every base told that, oh, okay, we know it because this is we know. Then another bee stand up and told, okay, I will try. And he comes very close to the fire and burns his wings and come back. Then we say, oh, the things is will burn my wings. Oh, all the bees, we know all this. Then again a bee stand up and told, okay, I will try. Then he enters the fire and totally burned down and dies. Then the old bees told that bee exactly know what the fire is. So that's why unless we enter the black hole, we can't say anything about the black hole. Thank you.
Well, thank you very much, sir. Now, sir has given thought-provoking lectures. Black hole itself is a very interesting topic. The whole global community is after this, and they're trying to find out more and more about this one. But still, there are many things which is mysterious, and all scientist community is after this. Hope we will arise of some good thing for us. But in the meantime, it is the time for the of those who joined as a student, they can ask a question to our Professor Farook Rahaman. So over to the audience. If there is anyone who want to ask question, unmute yourself and ask your question, please. Over to the audience. Anyone who want to ask the question? Anyone from the audience want to ask the question? Okay. Is there anyone? Oh, somebody has sent me a question. Okay. Just I would like to, on his behalf, I will try to put this question to the side. That while discussing, you were talking about that the formation of the black hole is due to the dust and gas. The dust and gas. So these two things mixed up and then make a black hole. This is what I think he has asked me to put this question to you. But question is, how in a particular place for the creation of the dust, there needs some sources. Gas is everywhere. But where from these dust will come, which will be quite enough to merge with the gas to give a black hole. So this is just a question from a student. Just enlighten us, sir. Yeah.
Okay. In classical sense, actually, black hole described or characterized by its mass and momentum and its charge. Okay. So mass, what the mass is constituted by which particular elements, that doesn't matter. So mass is the factor to form a black hole. Okay.
Right.
So we can see if any arbitrary mass, we don't know what the matter is constituted. That doesn't matter. If the mass has this with this special radius, as the mass has this special radius, then light cannot come out. So that mass become a black hole. Whatever elementary particles or whatever it has constituted.
So, sir, it means there's another question which is asked that in the absence of the hydrogen, because of that, if the hydrogen get finished, which is what you can say as the fuel for the existence, and if that fuel gets finished, then automatically it will collapse and it become a black hole. So just could a little bit elaborate this. One student want to know that.
No, actually, if actually there are some phases. If the initial mass of the star is less than 1.44 solar mass, then after exhausting all the materials, then the star starting collapse. Okay.
Yes.
Because there is no outward pressure. There is no fusion method and there is no outward pressure. Okay. Now there is a phenomena will happen, but due to enormous now the star is full of with helium. There is no hydrogen because all the hydrogen has been exhausted. Now the core of the star with helium. Okay. Now due to excessive gravitational force, the outer cell of the hydrogen, the electron in the outer cell of the hydrogen comes out. Okay. That is known as degenerate electron. And that degenerate electron again produce outward pressure. Then the star becomes a stable region, a stable configuration. That configuration is known as white dwarf. If the initial mass is more than say 1.44 solar mass, okay, then when all the hydrogen will be exhausted, now due to excessive gravitational force, all the electrons of the outer region of the hydrogen helium comes out. Then due to excessive extra gravitational force, all the electrons enter in the nucleus. So after entering the nucleus, in the nucleus we know proton. Then proton mixed up with electron produce neutron. Okay. Then there is enormous energy comes out, and that again we get a stable configuration due to this neutron. This star is known as neutron star. If the initial mass of more than the initial mass of the say 9 or 10 solar mass, initial mass, all the hydrogen exhaust. Okay. Now, due to excessive gravitational force, the stars again become collapsing. Okay, and due to excessive gravitational field force, the body after collapsing will reach a Schwarzschild radius. Schwarzschild radius. I have shown the formulation about the Schwarzschild radius. So when it is a Schwarzschild radius, then according to the result, one needs to more than velocity of light to comes out from this area. So the stars now become a black hole.
Sir, there is a Shyam Das. He is asking you to explain the shadow of black hole. About the shadow of black hole.
Oh, that is out of scope in this lecture. So I will discuss another day.
Okay, very good. There is one last question. There is one last question from another. Like a simple theory in a ratio, density is mass by volume. That we know. It's a grade 7. We learned this one. Now, when the density is going to be very large, so the volume has to be completely negligible, right? So and volume is negligible, means density is in fact becoming equal to the mass, right?
Exactly.
It can be so density will be becoming equal to the mass. How this is how a particular student in grade 10, grade 11 can understand this phenomenon?
No, actually not equal to the mass. You can't say this, but when volume tends to 0, then density becomes infinite. So infinite density. So that's why in our universe starts from this Big Bang, from this point like singularity, that is known as Big Bang singularity. Okay.
Yes.
So in that time, our whole universe has 0 volume, but density is infinite. So we can't say anything at this particular moment.
Yeah. So it is still in a theoretical position, right? So according to you, sir, majority of the things that you explained, we are more and more theoretical. It's all speculations on the basis of mathematics and all that. When you can expect that all these things will be mathematically or proven factually, so that it will become a rule or become a fact. So according to your experience, when it is going to happen? Probably.
It will be very difficult to say. So theoretically, we have to work more and more.
Yeah.
So actually, Einstein discovered his predicted gravitational wave in 1919, but it has proved after 100 years. So we can expect after 100 or 200 years, people definitely discover this.
So yeah, someone is raising hand. Someone is raising hand. Somi, I think, could you ask your question if you want? Somi Akhtar.
Okay, sir, thank you.
Yeah.
Yes. Sir, thank you for this nice presentation. Though I was not here from the very first, I joined in the middle of this lecture. Sir, kindly please let us know about the thin shell accretion disk.
Oh, that is actually that is
out of today's topic, I know.
It is not scope to discuss. So definitely, if I get some scope more, then I will discuss shadow. I will discuss accretion and whole things also. This is a more advanced topic. So in this lecture, there is no scope, I think. So definitely, I will discuss.
There is one more student, Samim. He is asking. I think you already explained this. Is there any man-made black hole, or is it possible to have a man-made black hole? I think you already described this, right?
Exactly. Actually, if you squeeze that man, into 10 to the power minus 33 meters. Okay, squeeze them is just like say Newton peace circle magic. You know peace circle magic? Peace circle magic. It just squeeze a man in very lower size. Okay, in PC circle magic. So in just like if we squeeze a man into 10 to the power minus 33 just centimeter just figure, then light cannot escape from this man's body. So the man, theoretically, that man becomes a black hole because no light can come out.
Well, fantastic, sir. Fantastic. But do you expect that if somebody managed to get this ability to excuse a human being, is it not going to become a weapon in the hand of the scientists? They want to finish the whole world like that. All human beings will be crushed to put into 10 to the power minus such mass. Exactly. So it is going to be another weapon. What do you think, sir?
Sure.
It will become another weapon. You don't have to use tank or missile and all these. You just use the technology to just crush the people to 10 to the power minus something, and the whole humanity will be crushed out. Is it going to happen? Something like that, sir?
So after advancement of science, I think you can get the answer.
Yeah. Okay. Thank you very much, sir. Is there anyone else? Because it's the time of concluding the program. It is already 7:30 as I promised to have 1 hour. So if there anyone else who want to ask, please come forward, because that you will not get this chance to have a person like him to reply to your question. So please come forward. I'm just taking 5 minutes more from sir. If you can, if you have any question, please don't hesitate and ask to sir. Anybody else? Okay, so thank you very much again, sir, that you have given a lot of information, and you are one of the top 2% scientists who is engaged in this one. Hopefully, your work in near future will be much more, and we will be like to listen to you again with some another important topic. May God bless you and give you more health and knowledge, so that you can be serving to the people, your community, your country, and a global community as a whole. Because a scientist is one of the biggest asset to any country. The country who has a large number of scientists are the one who is going to rule to the country in the near future. So hope that God may bless you and give you health and wealth, everything from this way, because more you discovered, more you have wealth. So I would like to conclude my program with thank to all those people who have participated. Without you, the program would not have been successful. I think all those who came over here must have been enlightened with all these facts that the sir had put into this PowerPoint presentation. I think these PowerPoint presentation, if the sir send it to me, I can be able to share it to my other colleague. Unfortunately, some of them could not join because they wanted to have it on Sunday, but because I already made this program, I could not change it to Sunday. Next time, we will see it. So thank you very much for this fascinating program. I also liked it very, very much. And with all of your participations, I'm indebted to you all, and see you again in our program. This program will continue to happen fortnightly. It will be after a gap of 1 week. There will be another one, and I will be bringing some other scientists or some academicians for your benefit. So please do join with me whenever I share you my flyer. With this, I will say you goodbye, good night. God bless you all. Thank you very much once again.
Thank you all. Thank you all.